Okay, so obviously I'm out today. I'll post this video for you guys later on the Google Classroom, as well as whatever video you guys will see in class. Okay. So today we're going to check your homework with your table. If you have any questions, please let the sub know. I'll give the sub a copy of the notes with each problem worked out, so you guys can see how it's done. They can put it up for you guys if they feel comfortable. They can work it through with you guys. All right, so we're going to work on your notes for 2.2, calculating the volume of prisms. Watch the video. That's this video, which I'll go through the volume of prisms with you guys. You'll watch another video. Well, I'll post other videos for you on the Google Classroom as well that explain it in different ways, different people explaining the same idea. And sometimes just watching a different video that'll make sense to you. Okay, but the only one you have to watch is this one because it's the one that you will be copying your notes from. And then you'll do what's big, great, and lives in California. That was the other side of the homework that was due today. So you'll do the back side of that to do some practice. And then we'll do the next lesson, which is slicing 3D figures. And watch Slice Master 2000, and there's a couple of other videos that go along with that as well. And then you work on your slicing 3D worksheet as classwork, and whenever you don't finish, this becomes homework. Okay, so 2.2, calculating the volume of prisms. Okay, now the volume prism says, for a prism with a fixed height and lateral surface area, how do the volume and surface area of the prism change as the number of sides increase? We did that part, so you don't need to copy that part down again. The part that I am concerned about is this section here. What general strategy can be used to find the volume of any prism, triangular, pentagonal, and so on? So we're talking about volume here this time. Volume, not necessarily surface area. So I'm not thinking about flat. I'm thinking about three-dimensional. So when you're talking about 3D shapes, okay, and we're talking about the volume, it's what we've done before, and this is something we've done before. We've done rectangular prisms before. And rectangular prisms, this is what we did. We started off with length times width. So we did length, and then we did width. So we did length times width, and then we multiplied it by the height, okay, which is our height, 12. Okay. That's what we did originally, and that gave us our volume. Now, much is the same with what we're going to do today. Nothing really changes except for this part down here, which is the base. Okay. This section, this first two, they make up that bottom section down there. That's what is length times width. This is our base. That base is the only thing that changes for this section. So for this first one, when we found the base, we did 8 times 5, and that gave us 40. This is the base. It's always going to be base, or the faces, the base, which is the bottom face that repeats, times height. Okay, times, in this case our height is 12. So 8 times 5 is 40 times 12. So what that means is this layer of 40 units repeats 12 times. Okay, so I have an 8 by 5 layer on the bottom, and then I repeat that layer 12 times. It's like a stack of books. I have one book that's 8 by 5 inches, and I have 12 books high. That layer shows up 12 times. I just multiply them together, and I get a volume of 480. In this case, inches cubed. Because the bottom one is 8 by 5, which is 40 times 12. And 40 times 12 is 480. So with this next section, with a triangular base, it's the same thing. A triangular based pyramid, or a prism, a triangle prism, what I need to do is I need to find the area of this triangle right down here. Okay. Now, the area of a triangle seems to be a little tricky for some of us. We might not remember it. So we're going to review how to find the area of a triangle a little bit. Okay. So I need to find this triangle base, and I'm going to have it repeat 12 times. Okay, that's my height, 12. I got one base, I repeat it 12 times. Okay, so the area of the base, so area of base times the height, times height, times height. Good. So area of base times height. Well, the area of the base, okay, let me draw this out a little bit. I'm going to use these numbers here because those are given to me, okay, are going to be, so it looks like this, that, okay, and those are all in the wrong color, so I'll fix that. Just delete it. Okay, so change colors. Here is my triangle. So here's my triangle. Okay, so I've got this length and this length, and this is my unknown. This one is my 8, and this is my 5. Now, whenever I have a triangle, to find the area, I have to find the 2 points or the 2 lengths that meet at a right angle. Very important that they meet at a right angle. So the 2 lengths that meet at a right angle are 5 and 8. So to find the area of the base, it's 5 times 8, and then we divide it by 2. Because triangles are half rectangles or half squares, one or the other. Okay, so this is my area of my base. Once I find my area of my base, I multiply that by the height. Okay, our height is 12. So I can do this all in one big group, or I can do it section by section. My height is 12. Okay, 5 times 8 is 40. So 5 times 8 makes, let's do this in a different color. 5 times 8 makes 40, and 40 divided by 2 makes 20. 20 times 12, well, 2 times 12 is 24. And then this is a 20, I'll add a 0. Inches cubed. What that means is in this bottom layer, or this top layer, whichever layer you want, what it means is there's 20 cubes here. There are 20 cubes, and that 20 cubes is repeated 12 times, etc. I don't know if that's 12, but 12 times. So 20 cubes and 12 layers of those 20 cubes makes 240 inches cubed. Okay. Now sometimes the area of the base will be a shape that we don't know. Like we know this is a hexagon. We know that, but we don't know how to calculate the area of a hexagon, or at least we haven't covered it in our scope and sequence in our lessons yet. So sometimes you have an area of the base already given to you. Sorry for the horrendous handwriting. Area of base, and that's given to me. You already tell me that in this bottom layer down here, I have 166 inches squared. I have 166 inches squared in that bottom layer, and I'm going to multiply it by the height times height. Okay, and my height is 12. Okay, maybe I didn't necessarily need that. Okay, times height. Oops, I did it again, which is 12, and 166 times 12 inches. I have 2 inches squared and 1 inch over here. My answer should be in inches cubed. Okay, so I have 166 times 12, which is, let me check, is 1,992. 1,992 inches cubed. Okay, so area of base times height. Okay, area of base times height is what we're looking for. Base times height, base times height. Base is the area. Okay, so we're gonna write this out nice and neat, and I'm gonna type this so it looks better than what I'm writing here. Okay, so volume of a prism. Okay, area of base times height. Okay, this part should be blue or red. My height I always do in red, and then my base I always do in blue. Okay, now it's important to note that the area of the base, okay, we need to know how to calculate that. So area of base, triangles, if it's a triangle, use some different color. Let's do, I don't know, purple. Area of a triangle is equal to length times width divided by 2, or times 1/2. Okay. Then you have rectangles, which is equal to, which you should know, just length times width. Capitalize this so I can separate it between the x. Length times width. Other shapes that you should know. Oh, wait. Keep this in mind that if you have it as a triangle, it should be meet at right angle. You have to meet at a right angle. That's important for triangles. Okay. All right. So once you have given this a try, if you're not sure, like, well, that still makes sense. There's a couple of videos. I'm gonna post a couple other videos on the Google Classroom for you that will have other people explain it in different ways, or just hearing it 10 different times might help. Okay, we have Chromebooks, but just please one per table, no more than that. The sub should be walking around making sure that you guys are on task. If you're off task, they will gladly put that Chromebook away, write your name down, and I'll email parents home, let them know that you're off task while the sub is here, which is not a good thing, not a good start to your day. If you are in my second block of the day, which is today was 5/1, 12, 6. If you're in my period 2, you're going to go out the sub to a fire drill. Please be on your best behavior, and I will explain to the sub where you're going, what direction to go. Please make it easy on them. That'd be great. Okay. All right. Go ahead and do some of the work. You can pause it here, rewind if you need to. And then we're going to work on 2.3, slicing of 3D figures. Okay. All right. So 2.3, after you've done a little bit of practice from 2.2, slicing of 3D figures, you should watch a couple of the videos first. Watch Slice Master 2000 first. Watch the one math shorts with the ninja slicing things. If you have time, well, you should have time. Watch the Khan Academy video next. Okay, watch the Khan Academy video next, and then with the slicing of the cubes, and I'll draw it out for you guys, and I'll show you how to draw them out on your notes. Okay. So watch those videos first, and then I'll talk about it. I might do some Play-Doh work here so you can see what it looks like. Okay. Okay, so you should have seen the slicing of 3D figures, the Slice Master 2000 video, the Ninja video, etc. So I'm going to draw a couple of them out for you guys, and I'm going to show you how to draw them out. Again, I know this is not an art class, but it really helps if your drawings are done to the best of your ability. The nicer it is, the easier it is to understand. Okay, so I'm going to start off with some of those cubes. Okay, so if we start off with a cube, I've been drawing cubes for a while, so I'm going to start off with just a simple square. Okay, let's focus. There's my square. Okay, and to draw my cube, I'm just going to have a repeating square. So I'm going to have another square the same size in the back. Okay, I might not need these two sections all the way through, but we'll see. And then I'm going to connect my corresponding sides, so top right corner to top left, top right, bottom right, bottom right, bottom left, bottom left. I'm going to redo these three and make them dotted lines so I know that they're behind. Okay. Alright, so I got my 3D shape, and I'm going to do a really simple slice. My slice is going to go across, parallel to this line here. Okay, parallel, and I'm going to draw a line vertical, which is parallel to these as much as I can. and then across this way, which is parallel to the front, and then this side, which is parallel to this side. Now my cross section is represented by this section in the middle. Okay, this shape that I end up making is a square. So if I cut it right across the center, no diagonals, just nice and parallel to the base, my answer will look like this. I have a square. That's my cross section. That's all we're doing today. I want to know what shape you get if you cut a three-dimensional figure. I'll do another square, or sorry, another cube. Okay, and again I overlap them just a tad. Okay, connect, 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 and then these will be dash lines instead. So good. All right. Now, I could get triangles. So you saw this. You should have seen this in the Khan Academy video. If I sliced this way, and then this way, and then this way, I would have ended up with a triangle slice. Now, the slice that comes off, the piece that comes off, ends up being a pyramid, a tiny pyramid. But I'm asking for the cross section. What does it look like if I open it up? It should look like a triangle. Okay? It'll end up looking like this, an equilateral triangle. Okay, an equilateral triangle. Now, I could do other triangles, like that's an equilateral triangle. I could do something like this, which is, I'm going to do a scaling triangle, I think. Oops, that last line's not so straight. Okay, so that one's a little bit obscure, okay, not quite equal all the way around. My cross section for the purple one would look something like this. I think that's what I drew. Okay, it looks something like that. Okay, so yes, please try and draw as neatly as possible with your shapes. Okay, I'm gonna draw a pyramid. Okay, and the nice thing about math and art is that they are very closely related. Okay, so if I draw a not a square but a rhombus, which is kind of like a square that got tilted. Okay, the whole sides are all equal length, but only these two angles are equal and these two angles are equal. They're not 90 all the way around. Okay, and if I put a point on top and I connect my lines, okay, that's my pyramid. That last line's not very good. It overlaps a lot. All right, there we go. Okay, now the ninja in the slicing video sliced horizontally. Okay, and if he sliced it that way, he ended up with, I know it doesn't look like it, but he ends up with a square. Okay, so ends up with a square. If he sliced it this way, like this line, and then went down, okay, and went that way, this line or this shape would have not been a square. It would have been a trapezoid. Okay. Now, if they had the pyramid, okay, I'll show you how to draw my pyramid again. Pay attention. Diagonal and a parallel diagonal over there. Okay. Maybe that's a little too long. Okay. Maybe I'll move this one over a little bit. There you go. That's better. That's more rhombus-ish. Okay. So if they cut it vertical, like straight at the peak over here, and then down there, and then across this way, okay, this one would have been a triangle. So it makes a triangle if I cut it at the very, very peak, okay? So that one makes a triangle, okay? I could cut it somewhere over here, and then this way, and then that way, and that would have made another triangle, okay? And that one would have looked something like this, maybe an obtuse triangle, okay? Something like that, okay? Good. Make sure your drawings are as good as they can get. Again, I'm not grading on your artwork, okay? on your test, they will give you something like this, and they'll ask you what the cross-section is. They might do something like this and ask you what the cross-section will look like. Okay, but spatial reasoning, the better you are at visualizing it in your head, probably the better the drawing will look like. Okay, probably the better the drawing will look like, and also the better your answers will come out. Okay, you have this assignment that you picked up on the way in that should look like this. Okay, and there are a lot of repeats, which is fine. So if there are some repeating questions, that's okay. You can get some practice in. Okay, all I'm asking you to do is draw the shape of the cross section. Good. Draw the shape of the cross section. Yours it's 4 pages, but it goes by really, really fast. Okay. So make sure you watch all the videos, the 2 Khan Academy ones, Slice Master, and the Ninja Short, which is Math Shorts. Okay. This will be posted online for you guys to see all of them. Also, don't forget to post your work online. There should be an assignment there as well for you to post it on.